All right, welcome back. We're looking at Tuesday's lesson, which is lesson 10. So today we're going to be focusing on interpreting inequalities. So trying to kind of figure out what they mean or how they could be used in some different real world situations. This lesson, we're going to be going through 3 different parts. You'll notice it says 10.1, 10.2, and 10.3. So this video may go over that 10-minute mark. It's probably going to. Sorry. I'll still try and keep it as short as possible. There are answers, of course, to check with once you've done the practice problems. Or if you opt to do the lesson 10 stuff in Khan Academy, you can do that instead. Or you can work on some freckles. So please do one of those 3 um, things to do some independent practice after the video. Don't forget, Mr. Morgan videos are available with the full lesson plus the practice problems worked out. So if you still feel like you need some support or longer, or even if you like him better, I'm not offended. Those are there. And then there's some extra practice stuff here. Now, this isn't to replace those top 3 things, but this is if you want to keep working on math and some fun extra stuff. There's an inequalities practice. And then I did link Prodigy here with a class code for you, and I'm going to put that across the week. But if you have ever played Prodigy before, it's pretty fun, and you can even play against your friends if you get them to log in at the same time. And then another just quick reminder that there's live math help every day of the week, whether it's with me on Wednesdays, Miss Fitz on Tuesday, Thursday, or Miss Jacoby Monday, Friday. We don't care whose class you're in. Feel free to jump onto any of those if you're coming up with questions or need some extra help. So with that, let's dive in. All right, sorry, just need to get this to open up for me. Oh, come on. There it is. All right, so interpreting inequalities. Well, we're going to start off actually looking at some equations just to kind of wrap our head around what we're going to be asked to do. So 10.1 here, we're doing some true or false. And we can do this with whole numbers, we can do it with fractions, we can do it with decimals. The idea is that we're looking to see if these equations are true. In other words, do they make sense? Are they balanced? We had talked about quite a bit about this back in workbook 6 when we were looking at the algebra stuff. So just kind of keep in mind that that equal sign is like the center of our balance board. So if you think hands-on equations, we want the left side of that equal side to total up to be the exact same as everything on the right side totals up to be. If they both end up weighing the same on each side of the equal sign, it's true. It's a balanced equation. If not, it doesn't work. It's false. It's not a correct equation. So the first one here, we've got whole numbers. I'm going to use this nifty little ink to math tool because I think it might even be able to figure out my handwriting, which is kind of a miracle. All right, so I'm looking at question number 1 there, and I've got multiple processes, multiple steps on both sides of that equation. So anytime I've got more than one step, I need to think about the order of operations. So that's that PEMDAS, please excuse my dear Aunt Sally, or however you remember that. So P being parentheses as the top step in the order of operations. I'm going to do what's inside the parentheses before I do anything else. So I'm going to start off with doing the 12 plus 5, which is, of course, 17. And 17 is then inside of a set of parentheses with a 3 attached to it. So that 3 is just sitting right next to that set of parentheses, which means that we have 3 of those. So we have 3 17s or 3 groups of 17. Whenever there's a number attached to the parentheses like that, it's really multiplication because we have 3 groups of that. So 3 groups of 17. Well, I know that 3 groups of 10 would be 30. 3 groups of 7 would be 21. So 30 and 21 together would be 51. So I know that 3 times 7 is 51. And that tells us that the left side of this equation is 51. 3 times the quantity, 12 plus 5, is 51. Now, what we need to check and see is if on the other side of that equal sign, we also have 51. We hope it does, because if it does, it's true, it's correct. So we're looking to see if this is correct, it would be 51 equals 51. Well, again, P parentheses, please excuse my dear Aunt Sally. We need to do what's in the parentheses before we worry about that dot in the middle, that multiplication in between those. So in that first set of parentheses, we've got 3 times 12. I know that one just as a basic fact is 36. Then it's got the dot, multiplication. But then I've got another set of parentheses. And again, parentheses comes first in that order of operations. So I'm going to do that. 3 times 5 would be 15. All right. And then with P parentheses, we don't have any more of those. E exponents, this problem didn't have exponents. Multiplication, division are the next part of the order of operations. Well, we've got a dot, we've got multiplication there. So 36 times 15. Well, 30 times 10, if I just kind of round, do some estimating on here, 30 times 10 would already be 300, and I rounded both of those numbers down significantly. So 36 times 15 would be way more than 300, which means there's no way it's going to be 51. So even without actually figuring out the answer, I know that this is not going to work. Oh, that's not a plus sign. That's supposed to be, let's see, maybe I slashed it the wrong way. Does not equal. There we go. That's what that's supposed to look like. 51 does not equal 36 times 15. So this equation is actually going to end up being false. So look at the next one here. We've got fractions, but don't let that scare you off. Multiplying fractions is actually the easiest thing we can do with fractions. As my home team will hopefully recall, when it comes to multiplication, it's easy as pie. Oopsie, it's 1/3. It's easy as pie, straight across the tops and bottoms, and you've got it. High five. I just need to see what that original problem was. 3/4. So straight across the tops, 1 times 3 is 3. Straight across the bottoms, 3 times 4 is 12. So if I go straight across the tops and bottoms, I get 3/12. Don't mind what my goofy symbols turned into there. Apparently that's a math symbol of some kind. So 3/12 is what the left side of that equation is going to be. 3/12. And we need to see, is that equal to the right side of this equation? Well, the right side of this equation is 3/4 times 2/6. Well, here again, when it comes to multiplication, it's easy as pie, straight across the tops. So across the top, 3 times 2 is 6. And bottoms, so 4 times 6 across the bottoms. 4 times 6 is 24. And you've got it, high five. Well, gonna erase all this middle stuff here. Hopefully, it's not negative. Why does it want to be negative? Hey, there we go. 3/12 and 6/24. Now, these don't look identical, but being equal doesn't mean it has to look the same. It means it needs to weigh the same amount, have the same value, essentially. If we think about like a balance board again, or those hangers that we had looked at. We could also think back to the ratios unit way back earlier this year when we did like the Gatorade. If we think about it that way, if 3 was the amount of powder we used, well, if we double the amount of powder to 6 and 12 was the amount of water we used, if we double the amount of water to 24, hopefully one of those things will spark a memory there that 3/12 and 6/24 are equivalent to one another. They would weigh the same amount if you sliced one pizza into 12ths and ate 3 slices, and a different pizza into 24ths and ate 6 pieces. You'd be eating the same amount of pizza. You would have the same value there. So this one, although it doesn't look identical, is in fact balanced or true. Oh, come on. There we go. Hey, it's even gonna work. That says true. Good luck reading my handwriting. Since it's taken a while to go through a couple of these, hopefully you're getting the idea. I'm gonna go ahead and not mess with the third one right now, since we had an example of one that was false and one that was true. And for the sake of time, I'm going to slide down here to 10.2 about a basketball game. If, however, anything I've said didn't make sense, make sure you get with us for some live math help. Email us a question. Just, we're happy to help. Let us know, please. Okay, Noah scored. Sorry, that line was me trying to scroll the screen up here, which apparently I'm not going to be able to do. Come on. Nope. Home. Okay. There. Oh, technology occasionally likes me. All right, Noah scored N points in a basketball game. So we're looking at, what does 15 is less than N mean in the context of a basketball game? All right, context. That word context there, another word we could use is situation. So in the scenario of a basketball game, in the basketball game situation, what does 15 is less than N mean? Well, N is points. So we could say 15 is less than the number of points. So if 15 is less than the number of points, then the number of points that were scored must be greater than, more than that. Okay, I was going to try and type. There we go. So in this situation, what this means then is that the number of points scored was more than 15, because 15 is less than N. So we're going to try one more of these context type situations where N is less than 25. So the number of points, N means the number of points. The number of points is less than 25. So in the context of a basketball game, the number of points, the N, was less than 25. So they could have scored 24 points, they could have scored 10 points, but they scored less than 25 points. So now we're going to create two number lines to represent the solutions to these inequalities. Now, this stuff gets really wordy, but I promise you it's not that difficult. So please try not to let the vocabulary here make you think we're getting into something really difficult. So create two number lines. All right, I'm going to go back to my drawing tools. Create a shape. Let's see. So maybe it'll let it be a line. Oh, it's a line, but it's kind of funky. Oh, it straightened that one out. Interesting. Okay, two number lines. Got them created. And I'm going to color code here. So I'm going to make this one in blue. And I'm going to do this one in pink. Oh, I'm still on the shape thingy. No, go away. I just want to draw. There we go. I hope that works. All right, blue one, top one. N is greater than 15, or 15 is less than N. Well, I'm going to put 15 on the number line here. And a few numbers greater, so 15, 16, 17, 18, and so on. And a few numbers below that, so 14, 13, 12. All right, so I've got some numbers bigger than and smaller than 15. 15 is the number that we are working with. So I'm going to take and put a circle at 15 there. And knowing that we said the number of points scored was more than 15, so the number of points could have been 16, it could have been 17, it could have been 100. It doesn't tell us specifically, other than it is more than. So when I make this graph, it could be anything higher than that. So I'm going to shade that whole side of the number line. Whereas on part 2, the second one that we're going to create, The number we're working with is 25, so I'm going to start with a 25 on that second number line. I'm going to put a couple numbers bigger, and I'm just going to say that that's 30 up there. And I'm going to make a few numbers smaller. I'm going to say 20 back here. I'm working with 25, so I'm going to put my circle at 25, my dot on that number line. I'm using an open dot because there's no, it's not saying less than or equal to. It's not including 25. So 25 wouldn't work here, but 24, 23, the number of points was less than 25. So 24, 23, 22, 21, 20, blah, 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 blah. They could have scored 0. So anything below 25 would have worked, which is why I am shading the left side of that number line. So when they ask us to represent it, they just want you to draw a number line, put your dot on the number that we're working on. You will need to pay attention to whether that's an open circle or a closed dot. And then you need to shade one of the sides of that number line. So we're going to name a possible value for n that is a solution to both inequalities. Both inequalities. Now I'm just realizing I should have drawn those number lines better, because really 15 and 25 shouldn't be lined up equal to each other. Live and learn, right? So something I should have done was put the 15 back further and the 25 up, because really there's going to be some space in between those. So a number that is a solution for both inequalities, well, on the blue one, we said it could be 16, 17, 18, 19, 20, 21, 22. And on the purple one, the bottom one, we said it could be 24, 23, 22, 21, 20. Notice I'm saying some of those same exact numbers again. Those numbers are anything that are in between 50 and 25. So higher than 15, lower than 25. It's going to be something that is shaded both on the blue one and on the purple one. So a possible value here would be a number that's written on both of those, or is shaded on both of those number lines. So the number 20 would be one possible solution. It's a number that would occur shaded on both situations. All right, now I gotta try and slide up again. Nope, hey, there goes too far. All right, so then name a possible value for n that is a solution to n is less than, 15 is less than n, but not n is less than 25. So now we want one that is a solution to the blue, but doesn't work for the purple. So we don't want it to work there. We do want it to work for this one. So 15 is less than n, the number of points. 15 is less than the number of points. The number of points is greater than 15. So 16, 17, 18, 19, 20 are all possible. 21, 22, 23, 24, 25 are all possible. 26, 27. Based on this, it could be anything up to infinity higher than 15. But based on this one, it can't go over 25. So to do a solution that is this, but is not this, we would need a number over 25. So we could say 26, or we could even say 100. That's a 6. Sure, that's a 6. Then we're asked, can -8 be a solution to n in this context? All right, well, if you look at this purple number line again, purple number line is shaded to the left. It's shaded going lower, lower, lower. They could have scored 0 points. However, in a basketball game, there's no situation where we have negative points on the board. There's no situation where you give away points. So even though that purple number line is shaded to the left and that number line does continue on forever, we would actually need to stop our shading at 0 because, and I'm going to try and type here. All right. Now I got to get technology to cooperate again. Because, okay, am I going to be able to type? Nope. Well, yes, but not where I want it to be. Let's try this. No, a basketball never has negative points. So that would be our solution, or excuse me, our answer to question number 6. And with that, that's going to wrap up this section. Again, questions. You can always check your lesson summary as a good place to look. Khan Academy has extra video supports. Mr. Morgan has extra videos. Or reach out and let us know if something doesn't make sense, please. We want to help you guys. We want you ready for 7th grade. So let us know if this isn't working or making sense for you. Please, please, please. The final thing I'm going to go over with you is these balanced diagram hangers, or unbalanced diagram hangers. Hanger diagrams? It's late. I'm talking backward. We see a diagram. Jada says that the weight of one circle is greater than the weight of one pentagon. Write an inequality to represent her statement. Let P be the weight for a pentagon and C be the weight of the circle. All right, let's do some drawing here. So she wants P for the pentagon. So we're going to call that pentagon P. And that circle we're going to call C. And we're going to write an inequality. Okay, that's just the mouth symbols. That's all an inequality is. So we're going to write an inequality for this image, this diagram. Well, the C, the circle, is hanging lower. It must be heavier since it's pulling that diagram down. So if it's bigger, it's greater. Our symbol is going to want to eat the circle. It's going to want to be open to the circle because that's the heavier, greater thing. So I'm going to open my mouth symbol, my inequality, toward the circle, the C for circle, which means that on the other side of that, on the side that is not as great or less heavy, lighter, we'll say, would be the P, the pentagon. So there's our inequality. Again, please try not to let this wordiness make you concerned here because what we're doing isn't hard. The vocabulary, though, can get you here. I understand if this vocabulary is a little crazy. So we're going to try one last thing. So a circle weighs 12 ounces. All right, let's switch up the color. Do some green. So a circle weighs 12 ounces. Use the information to write another inequality representing the relationship of the weights, then describe what the inequality means in this context. So sorry, I know my picture is covering part of that. Okay, so if we say this exact same thing, but we replace the circle, the C, with 12 ounces, we could say that the P is still lighter. That didn't change. It's still hanging where that's up higher on the balance on that diagram. So we could say that the pentagon, the P, is less than 12 pounds. Less than 12. So P is less than 12. It says then describe what this inequality means in this context. Well, to explain that, we would be saying that the pentagon must weigh less than 12 pounds. That's the situation or the context that we're in. Weights, shapes, and pounds are what's being used. Excuse me, ounces. Man, that says ounces. So 12, this is why I should have written labels because I'm misspeaking. Pounds and ounces have a big difference. So I need to pay attention to that. So actually we would say that the pentagon weighs less than 12 ounces. That's the situation. All right, guys, I know this was a long one. Sorry about that. Take care, and we will see each other. Actually, you'll see me. I won't really see you at that point, but you will see me hopefully again tomorrow when you watch the next video. I'm trying to end this one, and I will see you later. Bye.